body diagram for block M is, it has an FG because it has a mass. Because it is on a ramp, it also has an FG Y and FG X. As there's an FGY, there's also an FN, which is equivalent to the FGY. And let's see, it's being pulled up by a rope, so there is also a tension that is pulling the block up. As for part B, I forgot about the friction, which, as the tension is pulling it up the ramp, friction acts against the line of motion, so it will go this way, F(K), and kinetic friction because it's in motion. For part B, I'm gonna actually move this over here. For part B, the net force of the block is equal to the tension that is pulling the block up the ramp minus the opposing frictional force, as well as the force of gravity. We know that this is a singular rope that is going around these pulleys, and if I claim that this is pulling up, if I claim this is tension T, then the rope here is T over 2, the rope here is T over 2, and that makes F equal to T over 2. Now the problem says that that there is a constant velocity. Let me change this black, and therefore that makes ma that equals to 0. So 0 equals to T minus Fk minus Fg. We know that F equals T over 2, and if we multiply 2 over, that's 2 equals 2F equals to T. So I'm going to substitute that in for T. 2F let's see, F of K equals to, if where should I write this? F of K over F of N equals to mu K multiplied F of N over F N mu K equals F of K. And we know that F of N is equal to FGY, and let's see, FGY is equal to what's the mg cosine of theta? Because if this is theta, then let's see, FG, FGY, FGX, so like this, and we want to find FGY, that is adjacent over hypotenuse. Yeah, so it's mg cosine theta minus f of g made a few mistakes here. Is mg cosine of theta, which is the f of n and not f of k. It's f of n times mu of k, so that's have to multiply this by mu of k and minus fg. I forgot to include the subscript x here. This is fgx is what's putting it this way, and that is opposite over hypotenuse, so that is mg sine of theta. And so to isolate for 2f equals to mg cosine theta times mu k plus mg sine of theta, and divide by 2 over. As for the next question, if the angle is decreased, the magnitude of the applied force would also decrease. And the reason for that is because using our formula that we derived earlier said that the angle decreased, which means that let's see. So it would decrease because even though cosine of theta in here even though that increases, mg sine theta would decrease faster, because and how that works is on a unit circle, as you get angles that are closer and bigger to 90 degrees, the sine would get bigger because sine is your y value, and your cosine, which is your x value, would begin to decrease as the angle gets bigger. And inverse is true as the angle decreases. And the reason why I say it decreases is because as the cosine, mg cosine theta is multiplied by mu k, it will increase at a it will it will increase at a slower rate than sine of theta, because it's being multiplied by mu k, which is typically less than 1, but unless the friction coefficient is like stupidly larger, like friction of 4, which is not very likely to happen, the magnitude of the applied force would decrease if the angle was not as steep. Well, I mean, it kind of, based on that logic, it could depend. Like, it could be any of these three answers, but it is most likely going to decrease because in most real life scenarios, the friction coefficient is not going to be like that extremely large. For the next question, I'm going to be copying and pasting the force equation we found earlier. For 2. And actually it would use a different equation because there is now an acceleration, and the function we found above assumes that acceleration is equal to 0, so we can't use that. So we have to use net force equals to tension, putting it up, minus F of K, which is going against the motion, and Fgx, which is the force of gravity also pulling it down. And let's see, the mass is 5, ma equals F, and so this is 5 kilograms times acceleration of 2.1, and that equals to the tension, which, let's see, we said that tension equals 2F equals the tension, so 2F minus F of K, which is mg cosine theta times your mu K, so 5, 9.8 cosine of 37 degrees times the mu K of 0.24. Let me just move all of these real quick. Just make it smaller for more room. This is multiplied by 0.24, and Fgx is equal to mg sine of theta, which is what? This is 5 times 9.8 times sine of 37 degrees. And that should get us our, let me get my calculator. So let's see, in my calculator I'll also be adding both of these to the other side. So let's see, 5 times 2.1, that is 10.5 plus 5 times 9.8 times 0.24 times cosine of 37 plus 5 times 9.8 times sine of 37. So 2F equals to 49.38. Divide both sides by 2, and our applied force should be about 24.69 newtons in the positive direction, or the direction of the line of motion. Now for the next question, I don't know why I drew arrows here earlier. This is not referring to this image, it was referring to this image. But anyways, this is a different problem. I am going to move these a bit further up so I have more space. The free body diagrams for both blocks. I'm going to do the top block M. Well, let's see if does it say there is a friction? Yeah, in the next question it says there is a friction coefficient, so I mean I don't want to just assume there was, so if the line of motion is said to be going that way, then let's see, this has an f of g and an f of g in the x direction, as well as an f of g in the y direction. And if it has an f of g in the y direction, there is also an f of n. But if this is going to be, if the block wants to move downward by gravity, then the coefficient, not the coefficient, the friction would want it to move with the other block. So I'm going to say, why I'm not, yeah, I'm just gonna say F of friction, because I don't want to use F of K, since I'm not gonna, I don't want to assume that it is moving with the other block. It could be like sliding down, and I don't want to use F of K or F of S, so I'm just gonna put F of friction. And let's see, for the bottom block M, there is a tension putting it up, a F of G, F of GX, and F of GY, and that means there's also an F of N. But there is also not one but two forces of friction that are affecting it. One is the friction on the bottom here, which is F of K, because the block is moving, and also this force of friction that is moving, well, it's pulling the top block up, but it is also the force of top block is pulling the bottom block down. So I'm gonna I'm just gonna move the F of G's. Let's see, F of GY, I'm gonna move over here. F of GX, I'm gonna move right here just so I have more space to draw another F of friction of the top block. For the next question, it tells us about the mass of the top block. And it assumes that the blocks are stuck together, so we can just combine both blocks into one. I'm going to use the same formula as for part D, but just instead of a mass of 5, I'm going to plug in a mass of top plus bottom. 5 plus 3 equals 8 kilograms. So I'm going to write my calculations over here, part F. Let's see. Net force, MA, equals 8 times so 8 times the acceleration of 0, because it's in equilibrium, so it's not moving, and equals to the tension, which is 2F, minus the F of K of both blocks combined. So 8 times 9.8 times what's cosine of 37 times the mu k of the ramp, which is 0.24, minus, let's see, 8 times 9.8 times sine 37, and that is the FGY, and this cancels out. I'm gonna add these two terms to the other side to solve for F. Let's see, 8 times 9.8 times cosine of 37 times 0.24 plus 8 times 9.8 times sine of 37. That is 62.2, and that divide by 2. So 2f equals 62.21 divided by 2 equals 2. F equals 31.1. And that is a force in newtons in the positive direction. For part G, we need to find a minimum static friction to keep the top block stationary. So if we look at our diagram, it only has two forces going in the x direction, which is Fgx and F of friction. And let's see. So we can say that the net force of capital block M is equal to the F of static friction. I'm going to say static friction instead of F fric because we want to find a static friction minus Fgx, and we know what the static friction is equal to the we know that this is MA equals to mu S times Fn minus Fgx, which we know is mg sine of theta. We know that the Fn is equal to Fgy, so therefore we can take, I'm gonna add this over to the other side just to simplify things, and that is equal to 0 because we want the system in equilibrium, which means it is acceleration is 0. So it's mg sine theta equals to mu s, and f of n is equal to fgy, which is equal to mg what is it, cosine theta. And to isolate, we just this cancels. Is it just sine theta over cosine theta? Sine theta over cosine theta equals mu s, or tangent theta. There's no way it's that simple, right? So this is sine of was 37 degrees over cosine of 37 degrees, and that equals to 0.754, and that is the friction coefficient.